Yeah,
Shall we?
hey, how's it going, guys?
Yeah, okay, great. Before we get started today, a special shout out to the whole team that put this together. We've been coming to DappNode since the very beginning. Very exciting, one of the best conferences, and we're excited to be here. So shout out to everyone who put it together. Building on the great presentation given before us around stake decentralization and scaling the network, today Oshin and I are going to chat with you all about distributed validator technology, or DVT, how it can be helpful, what is it, who are the different user types, and ultimately, as post-merge, we're now transitioning into this new scalability era, one of which includes scaling consensus, and we'll break that down for you all today and explain what that means. So to get started, who is Obol Labs? Today, Obol Labs, you can best think of us as a research and development team. We're primarily focused on infrastructure for Ethereum. Today, primarily staking infrastructure. We have 14 members spread across 8 countries, quite diversified in our approach to technology and also in the way that we design our team. And right now, our sole and main focus is we're focused on the adoption of DVT through a concept called the Obol Network. What is the Obol Network? It's best to think of the Obol Network as a collection of open source tools that can help accelerate the adoption of trust and minimize staking. The Obol Network enables Ethereum stakers to create, test, run, and coordinate distributed validators. Our North Star here, as we think about ourselves as a project, is we want to enable Ethereum validators to be run by communities instead of individuals. Today, when you think of a validator, you think of a single entity, or you think of a single person. With this technology, and we believe the future of staking is putting the hands of validation into communities rather than just individuals. So how do you scale a blockchain? Today, Ethereum's roadmap primarily consists of 3 main areas of scaling. The first and most popular and most mature layer of this is the execution layer. Common technologies used for scaling this piece of the equation is optimistic and ZK rollups. Common projects here, Arbitrum and Starkware, Optimism. Today, there's many, many flavors of different types of ZK projects, which is great to see. The second area of scaling is known as the data layer. Data availability sampling is one of the primary methodologies used to help scale this problem. And today, we have Celestia, we have Polygon and Veil, and EigenLayer is some examples of projects who are working in this space. The third piece of the equation to scale is consensus, which we believe is the most important part. Distributed validator technology has been what the community of Ethereum has chosen to work with, implement, and mature as a primary means to scale the consensus layer. What does it mean to scale consensus? There is no perfect definition of this. We can provide some thoughts about how we look at scaling consensus as Obol as a team. First and foremost, your main goal in this is to increase the number of machines. Projects like DappNode and all of these other projects are here to help serve making it easy and accessible for the number of machines to increase in the network. So increasing participants, first and foremost, is how you scale. Secondarily to that, it's very important that it becomes easier and safer to become a validator. Distributed validator technology is something that is being formally verified. Therefore, what it can enable is an increase in liveness and safety at the same time for all validator types, which is very important for scaling. Accessibility and security is also extremely important. Today, as an AtHome Validator, it's a bit scary. The security isn't low, but it's not super robust. And if you're on vacation and your power goes out, your node will go offline. So ultimately, increasing security and accessibility at the same time is a large key to scaling. The last 2 pieces that we'll talk about have to do with slashing and different types of protocol risks that are created from the design of the protocol. So a major design element of how ETH2 works is correlated slashing and how it essentially disincentivizes people to have different setups rather than everyone having the same thing. Building middlewares like what we're doing with Obol, we'll spend some more time on an implementation later, and building all these other technologies need to be done in a manner where correlation risks are not increased in the network. And if we're building technologies and staking pools and products that increase correlation, well, then we're not putting ourselves in a great place. Ultimately, as well, lastly, no one likes to get slashed. It's very important that a lot of the time that we spend on scaling the network is done so in a manner that decreases the risk of slashing to users to enable an easier experience and more of a peace of mind-based experience.
So what is distributed validator technology? Distributed validator technology is the software that allows a validator to run across multiple machines. This is important because it protects you from software faults. You'll see later on that we run with quite a number of the clients, so software fails often enough, so you want to be protected from that. Similarly, hardware, most people will at some point, if they're running a validator, realize that their machine will die. And right now, there's no safe way to recover it or to fail over without DVT. Going a bit further, when you have multiple groups of humans running a validator together, that makes compromising the private key much more difficult because you have to compromise, 3 people to get a validator private key. And then lastly, if you're running in a multi-operator situation and something goes wrong and one client goes completely misbehaving, because these clusters are fault tolerant and Byzantine fault tolerant at that, that is safe, and the honest nodes will just ignore the bad acting node. So why does this matter, and where does DVT fit into kind of proof of stake in the journey we've been on so far? Proof of stake, most people know, has been discussed since before even Genesis, and the kind of first type of proof of stake chains you saw in production came about in about 2017, and most of them were delegated proof of stake, and they range between 30 and 100 validators. The original Serenity design came out in 2018, and that used the ED25519 curve and thought it could go to 1,000 to 10,000 validators, which set the floor at 1,500 ETH, which was still very prohibitive. Fortunately, with the adoption of the BLS signature scheme, we have more or less the design we have today, which can scale to the millions of validators, and it came to a threshold of 32 ETH. We see DVT as the next iteration of this, and we started this talk talking about how we can radically scale the consensus layer. We think if you split these BLS validators into groups and into clusters, you can get another order of magnitude growth. And the big thing that we're trying to get across is that these don't have to be all run by one person. You can have multiple humans or multiple entities running one validator together. So yeah, to talk a little bit about how it's implemented, you can implement DVT with a custom validator client that has total control over the private keys and can decide what to sign, but that is quite brittle and that introduces quite a lot of correlation risk. Instead, at Obol, we have built Charon as a middleware, and what that means is it sits between a normal validator client and a normal beacon client, and it intercepts the HTTP communication between them. Charon doesn't have any private keys, and all it does is, amongst its peers, it decides what every validator will be asked to sign, and then once the validators, which are the normal validator clients, check their slashing rules, say, this looks good to me, and sign it and return a signature, the Charon nodes aggregate them into a group signature and send that to the beacon node. And from there, the rest of the chain doesn't know that this validator is a distributed validator or not. What's nice about this design is it allows you to have lots of different clients. You can have different ELs, CLs, and validator clients. So we're going to briefly talk a bit about the kind of benefits of DVT and what they are for different entities. Each kind of customer segment, you might say, has different wants and different needs when it comes to distributed validators. There are the liquid staking pools, there are the trusted validators, there are the AtHome Validators, and there's kind of the new group called kind of collective or community validators. I'm going to start by talking a little about the liquid staking pools. The liquid staking pools, at the moment, they're decentralizing by taking in many new operators and giving many of the operators a small amount of their stake, but they still have to put a huge amount of trust into these operators. If one of them goes bust in the morning or someone kind of kicks their door in, that could be a decent percentage of that pool's stake at risk. If they adopt DVT, they can have multiple clients, or they can have multiple operators sharing in one validator, and the risk in any one operator is much, much reduced. This can also be used to scale the operator set, because you can start to mix trusted operators with untrusted home stakers. In, for example, a 4-node cluster, if you had 2 DAO operators and 2 home stakers, you can be sure that at least 3 people took part in every signing. We think that DVT and all of this tech will allow the liquid staking pools to kind of really become much more decentralized and grow their operator set and be, much more distributed for like the coming years. The other one I'm going to focus on are the trusted validators. This is the likes of your Coinbase, your Figment, your Block Daemon, and so on. These people, why they need DVT is maybe slightly different. For the most part, they hope to reduce their operating costs by having a fault-tolerant cluster that, if it goes down at night, no big deal. Their DevOps can sleep through the night. They can fix it in the morning. Similarly, with the robust fault-tolerant system, they can increase the amount of private keys per node and reduce their hardware costs. And some of the more out there things are slashing insurance. A lot of trusted operators, fund fully slashing insurance. This is very expensive when they have total control over a private key, because if they get compromised, the worst case outcome is total slashing. If you're running validators with others and you get compromised, the worst case is much less bad. So the hope is that we can reduce underwriting costs and over the medium term. I'll hand it over to Colin to talk about the other 2.
Cool. I'll spend some time talking a bit about how this helps the AtHome Validator. Recently, we've been doing a lot of user research around this, and peace of mind is probably the best thing that we've seen here. It not only has, again, its tangible benefits of like security and availability and ease of use, but ultimately it's peace of mind. If you're committed to being an AtHome Validator and you go through the process of doing it yourself and providing your own ETH, and you have 32 ETH and you're able to do it, you ultimately get to this process where your entire life becomes dedicated to making sure your machine stays online. Going on vacation is difficult. Going on long trips is difficult. You need backup power sources in your home. So ultimately today, like once you get through all the hurdles of being a validator, it's still quite stressful because machines die, computers die, software fails. It's ultimately how all things work. So enabling people from at home to spread their validator across multiple locations is a huge advantage. It enables people to withstand unreliable internet, power outages, and unforeseen issues. A prime example of this is inside of our core team today. We have a 4-node cluster running across Ireland, Cape Town, and India. And it's like with machines running out of people's homes. And we're able to really see what happens when you have not the best ISP connections or disruptions happen in local internet due to living in second or third world countries. And again, it's very important that these people become at-home validators as well. You can diversify your entire validator stack. This is also the last piece here that's very important for at-home validators. This enables them to, as Oisin explained earlier, have multiple different client choices, and they're able to build this anti-fragile setup. Community validators is the last personality type that we'll touch on today. This is a new category for us. This is the category, again, that we believe if we are successful with our mission, the majority of validators on mainnet will be run as collectives or communities instead of run by individual entities. The sooner we can kind of get this meme across to everyone that validators are to be communities and not individuals, the more successful we can become. Personality types here are DAOs, co-ops, partnerships. The DAO use case is very interesting. This week at ETH Berlin, we'll actually, as part of our hackathon, we'll try to put together the world's largest distributed validator with 20+ participants. We'll see how that goes, but that's ultimately a first example of like how communities can get involved and share validation rights instead of giving their tokens to a centralized person to stake on their behalf. And today we'll close it down with, validators are run by groups, not individuals. This is what we'd like to get across. This is what we'd like to instill mentally for everyone. And we think it's very important that the Ethereum validation community begins to move in this direction of abstracting away from the individual and looking at validators as run by communities. And with that, thank you everyone for the time today, and happy to take a few questions.
Are there any questions? Oh, yeah, there we go.
Thank you very much. I hope this question is fair. What is the differences between you and, for instance, SSV or Rocket Pool?
I'll take the Rocket Pool example, and then you take the other one. Rocket Pool, so our intention is to not come up the stack. We have no intention to provide smart contract infrastructure to create synthetic assets. Our whole main goal and our primary objective is to be an infrastructure coordination layer. It's a large enough job that a specific team needs to focus on it, and we prefer more of the legal profile of a project is solely only building infrastructure protocol. So you can think of Rocket Pool leveraging Charon as middleware for their users to build more resilient setups. So not in direct competitive to liquid staking pools, but here to help them migrate their products into the next evolution and chapter.
Yeah, and then on the SSV front, the main difference there is the SSV client is like a full validator client with custody over your private key and can decide what to sign. So we think that if that client goes past 33% or 50%, it can pose quite a big risk to the network. Whereas we've designed Obol, it doesn't have your private keys. The closest it comes is it facilitates you doing a key generation, a distributed key generation. But after that, it sits as a middleware to the existing validator clients. And God forbid, both of these were compromised. If you're a validator client, you have the private key, you can sign whatever. If Obol was compromised, it can be sign this, please. And the validator client will be that's flashable, I'm not going to sign that. So we think it's a much more non-correlated architecture and one that can kind of more safely be used by the majority of people, because we are of the opinion that highly available validators are the kind of future, and most people will be moving to this. So designing them to not increase correlation is a big thing of ours, and we'll be dropping an article that goes into a bit of this more next week.
Hey. So we're seeing that there's some talk about limiting the number of validators that are active at any given point, because there's basically a networking problem that we just cannot have all the computers in the world talking to all the computers in the world at the same time. How do you see solutions like Obol, which I think they're absolutely the way to go, they're adding to this network traffic, to this problematic traffic?
Very good question, and it's actually why we think distributed validators and middlewares are the kind of best way to solve this problem. A distributed validator, comes to consensus on what to sign outside of the main network. It's not using, the gossip network or anything like it. It's direct TCP connections to one another. So you can run your distributed validator, and it looks like a normal validator to the network. So we kind of talk about it as a second layer, or a second layer of kind of particularly scaling and mixing people in groups. But yeah, we've designed it such that we're not in the core protocol. And similarly, yeah, I kind of agree that the same way we had the roll-up centric scaling roadmap for Ethereum, I think we'll have a DVT-based scaling for the consensus layer. It's okay, take this off chain. The layer 1 will stay at probably 32 ETH, and it'll stay at a million or so validators, and the next 10x will come at the DVT layer instead of in the core protocol.
So what does this mean for people who stake Ethereum? And also you mentioned the significant scaling of the entire staking infrastructure, so how and why that will happen? So for people who stake in Ethereum, and how the growth will happen?
Yeah, it depends on where adoption of the technology takes place first. This is probably what we're learning the most interesting information about now from users. Everybody's keen to use it. Everybody has different ways to use it, but really it comes into where do we first see adoption? And in the crypto industry, we certainly don't see adoption first with the institutions. We always see adoption first with your AtHome Validators and or your DeFi projects. So today, for us, we're primarily focused on adoption where the most risk exists in the network. Today, the most risk exists in the network through the concentration of liquid staking pools. So when it comes to like adoption and getting these things standardized for the community, we're spending most of our, and allocating most of our time today with the liquid staking pools to help them scale and also de-risk the network. We think that that will be social cause enough to get everyone else to get on board, and that's how we're looking at adoption and getting it across the whole community. Wow, we finished right on time. That was nice. Cool.
Okay, great.
Thank you, everyone.
Thank you very much, guys.